Open Utility sysHYD is a comprehensive analytical modeling and network design solution for the hydraulic and thermal calculations necessary in pipeline networks. Open Utility sysHYD executes hydraulic calculations of pressure pipe systems with compressible and incompressible media like district heating, hot water or steam, district cooling, and gas networks. sysHYD has a simple data model. We only use nodes, pipes, valves, pumps, suppliers, consumer, and customers. In district energy, we use as a pipe, a supply and return network. Those networks are in most times similar to each other, so that we show this as one line network, and the calculation takes care on supply and return pipes. When the network is edited and all the parameters are edited too, we can start a steady state calculation. We can choose different simulations and change the parameters. For example, the load factor, or we have pressure maintenance controls where we can control the pressure on different net nodes. We have controls for the fixed pump head, that's the pressure different at a pump. We have the supplier, and we can put in a load prognosis. To run the calculation, we can push on the green button. The system will show us arrows. We have here on 3 nodes a pressure difference under 1, the minimum pressure difference of a consumer. We can change the parameters. We can create a second simulation, change the parameters in the controls, and in the pressure maintenance can run this calculation as simulation too. We see no error is popping up. We have a HTML report for the results. For example, we can see the minimum values of the pressure and the temperature for every node. There are a lot of more parameters. We can add costs for nodes and pipes to make a cost calculation. We can show the results on different views. We can change the views, for example, return and supply. And we see a colored network and different annotations, or we can see the pressure loss. For example, here it's a specific pressure loss, and we see that the pressure loss in magenta, that's the highest one, then the green one, and then the blue one. With different values, and the annotation will show the information of the pressure loss too. We also can create diagrams of the calculation. We can create a critical path, and I will name it path 10, and we can pick on the first node, that's a pump, and to a node in the network, and we can expand this to the critical path. Push on create and create a diagram about the critical path. Let's see, profile plot. We see here the path 10 brings this to the selection. I can show here district heating plot, and we can see a diagram with different lines. Change the diagram to the temperature differences. For example, we see that the temperature differences it goes down. Editing the data is very easy. If we would like to expand the network, we have here editing functions. We can create a pipe, for example. We can choose a mode and a node, and if we choose a new pipe with a node, we see here the parameters. As I mentioned, normally return and supply pipe in a district energy network is symmetrical, but we can change here the pipe types for supply and return, and we can change here the values of the pipe as well. For the parameters, we have libraries, for example, the pipe type library. If I click on the pipe type library, we will see here the pipe types. We can put in the parameter, or we can export to Excel, can change the parameter, can copy new pipe types, and can push this back to the sysHYD. We can also create design calculations. I go back to my steady state calculation on the 2B simulation. Click here on the design, and if we run this calculation, we can see here at the pipes there is a design result entry, and if I look at the design results, we can see here that the system proposal diameter for the existing pipe, and there are sometimes difference, and we can overtake this information in our design so that we have a proper design at the end of our work.